All right, systems of equations, substitution method. Now remember, systems of equations is looking for one thing and one thing only, the one point where the two lines cross. So if you are told, here's our system of equations for x plus y equals 5. And our second equation is 2x minus 3y equals 13. And you are told you must do this by the substitution method. Well, what we want to do is find the one variable, or any variable. I mean, all four of them might be, and you can choose whichever variable you want. In this case, we only have one variable that has a 1 coefficient. And then we're going to solve that equation for that variable. In other words, in this case, y equals. So I'm going to move the 4x to the other side. And now I have y equals negative 4x plus 5. So I know that y is negative 4x plus 5. Now, because I did this in use the first equation, I cannot put this into my first equation. It can only go into the other equation, the one that I did not solve for. So, because this is y, I'm going to take this and put it right in here. So for my second, I'm going to, catch this, guys, substitute it in. So I have minus 3. And this is my y now, equals, and make sure you're getting all the right numbers from the second equation. So minus 3, and that's y, and 13. Okay, so now I just need to do whatever it is I need to do here and solve for x. So negative 3 times negative 4x is plus 12x. And negative 3 times 5 is negative 15. Equals 13. So I just distributed this 3 into both of these. Now I've got some like terms I'm going to combine. So that's 14x minus 15 equals 13. Now I need to get the 14x by itself. So I'm going to add the 15 to the other side. And that will give me equals, x equals, let's see, 13 and 15 is 28. And then I'm going to divide both of these by 14 to get the x by itself, 14, and that's 2. So I know my x is 2, whoops. But I still need to come back here and in the original equation, put the x in and then solve for y. Choose either one. 1 or 2. I'm going to choose number 1. Okay, so equation number 1 is 4 and x is now 2 plus y equals 5. So now I just need to solve for y. So 4 times 2 is 8. And then I'm going to subtract the 8 from both sides and I get negative 3. So now I have my point 2, negative 3. But let's check it because these problems are all or nothing. You either find the one point where the two lines cross or you don't. You can't get close. So I'm going to have to give you all or nothing points. So take the second to check this and make sure that it works. Okay? You want all of your points on a test, none of them. Okay? Because that's what this will have to be. So this is equation number 1, and that's 8 minus 3 equals 5, and that's 5 equals 5. So it worked in the first one, but I have to do it in both equations. Hopefully you wrote these down before we started so you can see what they are. And minus 3 times negative 3 equals 13. 2 times 2 is 4. And negative 3 times negative 3 is positive 9. And 4 plus 9 is 13 equals 13. So my answer, of 2, -3 is correct. And this is the substitution method because we solved for a letter and then we substituted in what we got, this, into that y. So let's try another one. Okay, our second example. So equation number 1 is going to be -3x minus 5y equals -17. And the second equation is y equals 4x plus 8. And we are told we have to use the substitution method. Well, the second equation is already solved for one of the letters. You can do it for either x or y, but this one is already solved for y. Half the work's already done. I just need to take this stuff and put it right into this y. So that's equation 1 I'm going to be working with now. So minus 5 times 4x plus 8 equals -17. If it's already done for you guys, do it. Okay? Just dive right in and make it happen. Minus 40 equals -17. That's -23x equals, let's see, 40 minus 17. That's 3. So that's 23, and it's going to be positive. And so then I divide by a -23, -23, and I get x equals -1. Positive divided by negative is a negative, and 23 divided by 23. Now I'm going to put it back into equation number 1 or equation number 2. I think I'm going to put this one back into equation number 2. I could do either one, doesn't matter. So I get y equals, what is it? 4 times -1 plus 8. Okay, so I get y equals -4 plus 8. Y equals 4. So I've got my point, -1, 4. Let's check it. Guys, we can only check if we actually get a point. If you get 0 equals 0, all the variables are gone, like we talked about in the last video, or the 0 equals some other number, those you cannot check, because technically you would have to check absolutely every single possibility that ever existed. Okay, so only if you actually get a point do we check. Okay, so equation number 1 is negative. Get this back out here. So -3x, -3 times -1 minus 5 times 4 equals -17. Okay, so -3 times -1 is 3, -5 times 4 is -20, equals -17. 3 minus 20 is -17, equals -17. Well, that worked, and now we need to check it. Remember, you have to check it. It has to work in all equations. So this one's y equals 4 times -1 plus 8. So that's 4 equals -4 plus 8. 4 equals 4. So there we have it. Now, can you use the substitution method on every single systems of equations? Absolutely. Do we want to? Definitely not. And let me show you why. So let's say we'll go back to one we had in the very first video, or the second, I think it was actually, equals 19. And then we have this, 3x minus 7y equals -6. So I need to just choose an x or a y in equation 1 or equation 2 and solve for it. So I'm going to choose x in equation number 2. I'm going to solve for x. So I'll start by moving the 7y over, and then I'm going to divide everything by 3, and so I get x equals 7/3 y. Oh, in this case, it worked out better than I would have thought, but I still have a fraction that I'm going to have to work with, okay? So here's my criteria, guys. Alice's criteria, okay? I don't care what the directions say, whether I did them or the book did them, but if it doesn't meet my criteria for doing substitution, then use the elimination method. And my criteria is that at least one, so let's look up here, at least one of your variables has to have a 1 coefficient. C-O-O-E. Okay? That way, when we solve for it, we don't end up with fractions. So like this one had a variable with a 1 coefficient. This one, when we did it, it already was solved for the variable that had a 1 coefficient. But if it does not, if none of the variables have a 1 coefficient, then we would use elimination. Not that we can't use substitution, and some teachers may make you do it, but again, why, when we have another method that's easier, do we do something that's super hard when we don't really have to? So there, guys, is systems of equations looking for the one point where the two lines cross. Have fun.